In this video we'll look at isocontouring using a defined SUV threshold. Now, isocontouring is really useful because it allows this careful control of the voxel inclusion threshold, and the search area can also be confined to a boundary that you set before activating the isocontour algorithm. It tends to be particularly useful for PET and SPECT data where there's high tracer uptake in a given region or organ, but it can also be used to segment bone, lungs, or contrast-enhanced lesions in CT or enhanced areas in MRI as well. For this exercise, we continue in the View tool. And again, we'll select from the demo database the subject pseg2. So you can use the filter for the database, enter PS and press enter to update so that we find subject pseg2. And then from the series list we'll select the PET 3D, add that to our loading list and open. Again we see this whole body PET including a number of lesions, and we'll start by turning on the MIP display and again invert the grey colour table so that we can clearly see the lesions and high contrast areas in the image. We'll use isocontouring to segment the lesion near to the heart using a directly controlled SUV threshold. So when the SUV information is included in the image header, it's very easy to work with SUV units. To see that SUV information, we should open the series information and editing window. This is the small I icon in the top right of the image display. And in the dialog that opens, in the lower right, we have another dialog for edit subject or study info. In that particular dialog, we have elements of the DICOM header. On the first tab in the lower portion, you see the study and series information, where we have timing for study, series and acquisition. And then the second tab is our SUV parameters. For SUV body weight, we need at least the body weight, the acquisition time, the isotope, the dose and the administration time. And then PMOD can automatically calculate the dose at the image decay correction time to use for SUV. So in this case, we don't have an image decay correction time. It was not used at the time that this DICOM data was generated, but we do have an acquisition time, we have the half-life, radiopharmaceutical, although it's not strictly necessary, the dose that was injected and the time it was prepared, allowing us to calculate the dose at the image decay correction time, in this case the acquisition time. Everything is there that we need, including the patient body weight, so we can close this dialog and close the series information dialog. From here we can proceed using the workflow to the VOIs tab. And now we'll set up the boundary box that we want to use for isocontouring on the lesion near the heart. So we can use the MIP to triangulate that lesion, and then we can use the zoom controls at the bottom of the image display to zoom in by a large factor on that lesion close to the heart. And we'll start by creating a sphere boundary around that lesion, which will then target our isocontouring process. So we can use the sphere tool to create a new VOI, and a radius of 25 millimeters will work well for this lesion. I can create a new VOI, and we see our sphere created in the image. If the alignment was not perfect, you can still use the interactive controls to reposition it as you want. Now in fact, since we have the SUV information in the image header, we can change the units at any time. The small icon to the left of the lower threshold for the color table allows us to choose between available units. So we have the original units and then a number of SUV variants, the most common of which is the first, SUV body weight, with units gram per mil. And finally we have an option to create percent injected dose per mil as well. For now, we can keep the original units, and we'll see the effect of this choice during the isocontouring process. So now we can open the isocontouring dialog. We immediately see a change in our boundary contour, but we need to set up the algorithm first of all. So select Set Defaults in the top right of the isocontouring dialog, and this will set the 3D hot searching algorithm without inner holes or multi-regions. And by default, it will use a percentage based on the maximum minus minimum in the image of 50%. Above that percentage setup portion, you see we can use an exact value as well. And at the moment it shows the units kilobecquerel per cc, and these units, or the value, corresponds to the percentage that was set below. If we want to use SUV here, then we can now change the units using the shortcut near the color table to SUV body weight, and we see the SUV value change. Then we can enter a new meaningful value, for example an SUV of 5, and now pixels included in our VOI for this particular lesion are only those with an SUV body weight above 5. So I can confirm that for generation of my contour. I still have the option to change the image units to something else, such as back to original, without changing that particular VOI that was created. And now we can calculate the statistics for this VOI. If we use selected statistics, we can make sure that we include the interesting parameters for such an FDG PET. So we will want average as SUV mean, the volume, and then we can take max for the SUV max. When I click OK, we will generate the statistics. So now, since we had original units set on the color table shortcut, we see our parameters, which can all be selected on the right hand side, with the units kilobecquerel per cc or cubic centimeters for the volume. And then in fact in the statistics viewer in the top left, we can change between SUV and kilobecquerel per cc as we want, given that SUV information in the image header.